Okay, so today we're gonna do October-November 2023 paper 11 of A-level mathematics, AS level, paper 1, pure mathematics 1. Okay, right. So let's move towards the first question. The first question is from the binomial expansion. It says that expand this in ascending powers of x up to and including the term in x squared. Okay, which means that so ascending power of x, right? So the powers of x should be increasing. Now, we'll start from obviously the x to the power of 0, right? That's the least power of x you can get. And then x to the power of 1, and then x to the power of 2. So these are the three terms that you have to find. Now, using the formula for the binomial theorem, we have NCR. So NCR A to the power of n minus r, and then b to the power of r. That is how you expand. Right now, what would be your r, right? So as you can see that here our x is in the second term, right, which is the b. So the power of b using the formula will be r. So whatever the power, the r is, the power of x will be the same. So if we have to make the power of x 0, so we have to keep r 0. And if we have to make the power of x 1, we have to make the r 1. And same for the 2, right? So let's start. So um, for for the situation when you have to keep the power of x 0. So let's see, NCR, right? So n is in this case is 6, so 6c 0. A is 1 here, so 1, and to the power of n minus r, so 6 minus 0, which is 6, and then 3x to the power of r, so the r here is 0. So yeah, okay, so that is how you do it for to calculate the coefficient of power of x to the power of 0. Okay, now let's do the same for x to the power of 1. So 6c1, 1, and raised to the power of n minus r, so that would be 5, and then 3x to the power of 1. Okay, and then same for where we have to find x to the power of 2. So that would be 6c2, 1 to the power of 4, and then 3x, and then r here is 2, so that would be 2. Okay, now what is 6c0? 6c0 would be 1, right? And then 1 to the power of anything is just 1, right? So there's no use of writing it. And then anything to the power of 0 is also 1. So our first like the term with the coefficient of x to the power of 0, which is basically nothing, right? There's no x here, so that would be 1. And then let's see for the x to the power of 1, where we have the coefficient with x, right? That would be 6c1, which is 6. 6 times 3 to the power of 1, so that would be 18. Okay, so 18x. Now let's do the same thing for x to the power of 2, right? X square. So that would be 6c2 times 3 square, right? Because the square is on 3 as well as the x. So yeah, that would be 135. So 135 x square. So these are the three terms that we have in the ascending order of x up to x squared. So 1 plus 18x plus 135 x squared. Okay, that's it for the first part. Let's move on to the second part. Hence find the coefficient of x squared in this expansion. Okay, so let's see. So what can we multiply this? Okay, so if we multiply 1 by something x square, so the answer we will get is would be like the in the coefficient of x square, right? And similarly, if we multiply this x by x, so we know that x times x is x square, so that also works, right? And for x square, if we multiply x square with something which has x to the power of 0, so that would also give us x square, right? So let's see. So we already expanded this in the previous part. So let's see how this works. So we have this, And we can use the expanded version, which we already did in the previous part here. Okay, so that would be 1 plus 18x plus 135x square. Okay. Now, if you multiply this 1 by this 135x square, that would give us a term in terms of x square, right? And then we have this 7 minus 7x. If you multiply this minus 7x by this 18x, we would also get something x squared. Okay, and then x squared times 1 is x squared. So it also gives us like in terms of x squared. So that is what you want, right? So let's multiply these. So 1 times 135 is just 135x squared, and then minus 7 times 18. So minus 7 times 18 would be minus 126 x squared, and then 1 times x squared is just x squared. So 135 minus 126 plus 1, that is 10. So that is 10x squared. So the coefficient here is basically 10, right? That is the coefficient of x squared. Right, so that was for the question number 1. Let's move towards question number 2, which is of 4 marks. Okay. Okay, so a line has this equation and a curve has this equation. Okay, where C is a constant. So all the necessary working, determine which of these statement is correct. So we have 3 statements given. Okay, so the first statement A states that the line and the curve intersect only for a particular set of values of C. The line and the curve intersect for all values of C. The line and the curve do not intersect for any values of C. Right. So, so how do we approach these type of questions? So the first thing that we have to do is to basically figure out b square minus 4ac, right? So we know that using b square minus 4ac, we would know that where do they intersect, okay? So let's see. So we can equate these two. We can equate this line and we can equate this curve. So that would be 2cx plus 3 is equal to cx squared plus 3x minus c, right? So these are, this is after we equated these two, because we know that they are both equal to y. So we can just equate these two equations for the curve and for the line. So now let's make this like, or let's make all the terms on one side. Let's bring them on one side. So cx squared plus 3x, and then we can bring this on the other side. So that would be minus 2cx minus c minus 3 is equal to 0. Now what we can do is we can like write it properly. So the coefficient of x is clear. So if we take x common here, so that would be 3 minus 2c, right? Minus c minus 3 is equal to 0. Now we know that our a here is c, our b here is 3 minus 2c, and our c here is minus c minus 3, right? So b square minus 4ac. Let's see what this gets us to. So b square would be this squared minus 4, a is c, and then c here is minus c minus 3, right? Now let's square this. So that would be 9 minus 612c plus 4c squared. So minus 4c, and then this minus 4c is getting multiplied by these two, right? So let me just do this in the next step. So that would be minus 4c times minus c, that would be plus 4c squared, and then minus minus is plus, and then 4 times 3 is 12c, right? So 4c squared plus 4c squared is actually 8c squared, and then this cancels out, minus plus 9. Okay, so we know that whatever the value of c is, right? Whatever the value of c is, whether it is it is positive, whether it is negative, right? So all the values of c, it comprises of all the values of C basically, right? Whether it's positive, whether it's negative, and whether it's zero even. So for all the values of C, if we square something, so if we square a positive number or a negative number, we are gonna get something positive, right? 2 square is 4 and minus 2 square is also 4. So that it's not possible that we are getting something negative for this whole expression, right? Whatever the value of C we put in here, we're gonna get a positive answer for this whole thing, which is 8C squared plus 9, right? So we know that this is greater than 0, right? So we know that it intersects at any value of C. How can we say it intersects at any value of C? Because we know that for any value of C, whether it's negative or whether it's positive, we're always gonna get this greater than 0. And when we know it's greater than 0, we know they intersect, right? The line intersects um at the curve and the line intersect. So so according to that, we can infer that statement B is correct, right? Why? Because the line and the curve intersect for all values of C, whether the C is positive or whether the C is negative. It doesn't matter here, right? For particular values of C, not really. It intersect for all values of C, right? And does not intersect for any values of C? No, it does intersect. Why does it intersect? Because that would be greater than 0, right? When B square minus 4C is greater than 0, the line and the curve intersects, okay, at two distinct points, right? So that is our answer. So we can say that B, right? B is correct. B is correct, okay? Because um because 8C squared plus 9 is greater than 0. So line and curve intersects for all values of C, okay? So